Hello, we're going to be looking at example 1 on page 758. This is in your pre-calculus lesson 7.3 on partial fractions, example number 1. And on this particular problem, this is a very lengthy problem, as many of the problems get in the pre-calculus. We're going to find the partial decomposition, partial fraction decomposition of x plus 4 over x minus 4 and x plus 2. And there's a process that you have to follow, as you're going to see as we go through this solution here. So as we do, I need for you to look, as we begin, first of all, you have to understand that x plus 4 over the, x plus 14 over the x minus 4 and x plus 2 can be divided into a, we're just calling that a, we're going to have to find out what a and b are, but something over x minus 4 plus something over x plus 2. We're going to split the two denominators. We're going to split the two denominators so that we can do that. Now, once we do this step right here, our goal, of course, is to find a and b. So to do so, we're going to have to simplify this new, right here, the new, what I want to call it, the equation that we have here. So I want to eliminate the x minus 4 and the x plus 2. So in order to do that, we have to multiply by what's called the least common denominator, which is the x minus 4 and the x plus 2 right here and here. When I do so, as you can see down here, these two are going to totally cancel each other, and I'm simply going to be left with the x plus 14 on the left side of the equal sign. Now, what you do on the left side, you must do on the right side. So when I take the right side and multiply it by x minus 4 and x plus 2, then when I multiply it by the first one, or the a, only the x minus 4s are going to cancel each other. As you can see, let me raise this up a little bit. Only the x minus 4s are going to cancel. So you're going to be left with the x plus 2 times a, which is what we have right here. In the second one, when you multiply all of this by the b value, which we're doing right here, the x plus 2s this time are going to cancel. So you're going to be left with b times the x minus 4. All right? Now, as we progress on down from that, we end up with this equation right here. So what we have to do is we have to understand that if I distribute all this out, this becomes ax plus 2a, which is what you see right here, and this becomes bx minus 4b, which is what you see right here. Now, if I combine or get my x's together, I have ax plus bx, and then I have 2a minus 4b. The ax and the bx together become a plus bx. All I did was factor out the x, and you're left with a plus b. Well, if we compare x's with x's, this part has to be equal to this part right here, which is the x on the other side. And so since that number is 1, then the a plus b has to be equal to 1. And the 2a minus 4b, which is the constant part of it, both of those together have to end up being equal to 14, which is why you see the blue arrows there connecting those two. Now, if I set those equal, I end up with two equations. The original was the a plus b equals 1, which is what we have right here, and the 2a minus 4b equals 14, which is what we have in the second equation. Now, this becomes a system of equations that hopefully by now, because in Algebra 2 as well as in the pre-calculus part 1 section, we kind of worked on how to do systems of equations. But that's exactly what you're going to be doing, and I'll do that in the checkpoint when I'll do all of that together. But that's where they came up by doing all this. That's where they've come up with the answers that they have. They found out by working, again, systems by elimination or whatever process you want to do. They call it the addition method. But they found out that a was equal to, excuse me, I've moved it too far. They found out that a was equal to 3 and that b was equal to -2. Okay, So what they simply did was go back to the original equation where you split it up into the a over x minus 4 and the b over x plus 2, and you're going to put 3 in for a because that's what they found out a to be, and they found out b to be the negative 2. So it could be written this way right here, or it could be written 3 over x minus 4 minus 2 over x plus 2. Both of those are actually saying the same thing. Now, this part in blue is what literally you're going to do. It's telling you the steps to do partial fraction decomposition, and if you'll follow those step by step by step, then you will get the answer. Okay, so let me work this one with you by doing this. Now we have this, so we know that 5x minus 1 is going to be equal to the a over x minus 3 plus the b over x plus 4. And remember, ultimately we're trying to find what a and b are. Now, I'm going to kind of take a shortcut, but what we're going to have to do to get rid of these two fractions here and here on the bottom is we're going to have to multiply both sides by x minus 3 and x plus 4. That's what's going to get rid of the denominators there. When I do it to the first one, the 5x is over x minus 3, x plus 4. I don't know why my pen acts up so badly. X minus 3. Anyway, when I multiply, these two are going to cancel each other. So I'm just going to be left with 5x minus 1. On the right side, when I multiply all of this by all of this, I end up, remember the x minus 3's are going to cancel each other. So I'm going to be left with the x plus 4 times the a. And for the other one, when I multiply all of this by all of this, the x plus 4's are going to cancel. So I'm going to be left with the x minus 3 times the b value. Okay, so as I multiply all of that out, I'm going to get ax plus 4a plus bx minus 3b is equal to the 5x minus 1. Okay. Now, if I put my x's together, which is right here and right here, I'm going to get that ax plus bx plus 4a minus 3b. What happens here is the x's have to be equal to the x's. So we end up with an equation here ultimately that says a plus b equals 5, because these are acting like the coefficients, just like that one is acting like a coefficient. So a plus b is 5, and then these two have to add up to be the negative 1. So 4a minus 3b equals negative 1. Now, okay, so what we're going to do here is, here we would do a system of equations. I'm going to multiply the top one by negative 4 so that these will be opposites of each other. When I do, I end up with negative 4a minus 4b equals negative 20. And at the bottom, I end up with positive 4a minus 3b equals 7. When I add these together, these are going to cancel each other. Oh, that's not 7. Excuse me, that's negative 1. Excuse me, mislooking. So we end up with negative 7b is equal to negative 21. Because you have two, that's negative, and so is this. So when those are both negative, if I divide both sides by negative 7, then b ends up being positive 3. So we found half of that. Now, if you go back to either one of the originals, like that one right there, then you could say a plus b equals 3, equals 5. And I'm going to substitute the 3 in right here for b. So it's really a plus 3 equals 5, which means a is going to end up being 2. Okay? Now, I found a and b. A is 2 and b is 3. So I can rewrite this equation 5x minus 1 over x minus 3 over x plus 4. I can make that now equal to, remember the first one was a, but we know a is now 2. So it's going to be 2 over x minus 3 plus the b, which we found right here, is 3 over the second one, which is x plus 4. And this is what we call partial fractions. And this is the way we do it, and that would be your final answer. I hope this helps a little bit. I know this is a long, complicated process, but you can make it through.